All right. Hello and welcome. Happy week 10. Crazy. Time flies. We got a lot to do again today in the next hour, hour and a half or so. Again, we have to leave at the top of the hour. That's totally fine. Michelle, George, thanks so much for joining. Karen, always great to see you. So I want to review some logistics just around the expectations for how to submit the capstone, how to finish this course, and kind of get all the grades that you want. So we'll start with some of those logistics. And then there are three, I guess, mini projects in week 10. The first is creating interactive maps with Folium. The second is creating interactive dashboards with Plotly Dash. And then the third is the machine learning deliverable of actually training our model to predict the probability of that launch stage failure. So yeah, I think we'll wrap all that up. So big ideas. Week 9 was all about the data engineering and data ETL for this project. So we extracted data from two different vendors, the API, SpaceX API, and the Wikipedia page for SpaceX launches. We then parse that data, parse the JSON, normalize the JSON, parse the HTML, normalize the HTML. We then joined all that data together and saved it off to a SQLite database. Again, this is very consistent with ETL practices in real life. We then wrote some exploratory data analysis queries against that SQL database, as well as made some visualizations in Python and Matplotlib to explore the data as well. In week 10, we're going to be taking that business ready data and creating business ready data products. So, this is the second half of the data science ecosystem. Once we have our data loaded and ready and cleaned, we're then going to take that data, make business ready dashboards off of that data, business ready reporting services off of that data, as well as train some predictive models. And then in the future, you could also then incorporate those model inferences in your business reports or save them back to the database or even use them as live model serving. We've talked through a lot of that at high level in past lectures through ML Ops. Cool. So let's jump to kind of what's expected for your deliverables for the capstone. So for the capstone project, you're going to end up submitting it through this IBM campus ecosystem, I guess. And if I pop over into 10.8, I actually don't think I have the full permissions to see this, but you should be able to submit your GitHub link. And we'll walk through what I expect in that GitHub here in a sec. But there should be a link here. This is in module 10.8 media set. You have a step-by-step guide on how to upload your assignments. I would recommend doing a text submission, and the text submission will contain the URL for your GitHub. That would be, Karen, correct if I'm wrong. I think this is how I wanted them to do it. I don't know if you've gone through this yet, but it looks like, unlike last year when we had like the submit URL, they only have the submit files and submit text. So what I would do is use a text submission. You gotta say something like, here's the link to my Capstone portfolio repository. Paste in the full URL, and we'll walk through what that would look like, and then submit it. So that's how I would recommend submitting it. I know that we'll probably get some students that submit just the PowerPoint or write-up as PDFs through file submission. But for Karen and me's sake, I would rather see your full portfolio, including all the
Um,
notebooks, images, database, and obviously your reports as well. So I would prefer to see the full repository.
yeah, I'd say that's good. They could scroll up. They could do that part below for file submission. They could do their presentation file in there, and then make in the as you put that in the text, put the URL for their GitHub.
So first priority,
Does that
try and
work? Does
submit
that
the.
sound good? Does that
I don't know
sound
if they
good?
can do both as a submission. I think it's one or
Oh,
the
it has to
other.
one or the other. Okay.
Yes. So I would recommend to try and do the text submission first and submit the repository, and then as a backup option, you can use the file submission and just load in your PowerPoint and report. But my preference would be to see the full repository if possible. But Karen and I will grade as much as we can because I know that there's some students that were struggling with GitHub already as well. So you have two options. First is a straight file upload if you're not able to get GitHub to work or you're having trouble with your repository or whatever. I get it. That doesn't mean you can't get a grade on the capstone. Just upload your PowerPoint and your write-up optionally as a file submission. Otherwise, submit your repository link as a URL
Or
through the text submission.
or in that other case, they could make a zip file of the notebooks and
Yeah,
the
I've had
file.
issues with zip files
Um,
with this platform, but yeah. Either way, I think Michelle, George, I fully expect both of you to have repositories submitted through URLs because I know you're both very capable of making GitHub repositories work. So,
yeah,
all
because
right.
I like the GitHub because with the notebooks because I can pull down the whole GitHub and I
Yep.
can run the notebooks and stuff.
Yep. So just now I want to go over quickly what I expect you all to submit. So as we reviewed in our live lecture last class, let me open up repositories. It's expected that you will create a new repository on your GitHub portfolio, call it IBM Data Science Capstone, SpaceX Capstone, whatever you want. And then we walked through how to upload files and folders to GitHub. What the easiest way and what I recommend doing is organizing the documents for your submission on your local machine. So for my end, I think like I showed you how I organized some of my folders or whatever and organized like this. Then once you have it organized, this can be through Finder on a Mac or File Explorer on Windows. Once you have your stuff organized and ready for submission on your GitHub repository, go to Add File, Upload Files, and then you should be able to drag and drop your content directly into this repository and commit them straight. And it should just work where you see the folder structure, even if you had subfolders and stuff, you should be able to get all that folder structure as well as the files uploaded into GitHub. And then this is the URL that you would submit for your text submission when we get there. So what I expect to see is I expect to see all the notebooks from not week module 9. So that includes modules uh, 9.4 and 9.5. So I think this was the extraction notebooks. Yeah, API and web scraping notebooks and wrangling notebooks. And then for 9.5, the SQL and EDA notebooks as well. So I see 5 notebooks as well as some of these CSVs. And then for week 10, it'll be the 3 small parts of the project that we discussed earlier. Your Folium maps, your dashboard, and your machine learning notebooks. We walked through how to download these files in the session thread. So if you check on either this one or maybe it was a module 9, I think it was the module 9 lounge. We walked through how to download um, files uh, from the workspace. I'll show you again how to do that today. One thing that's come up over the last couple days is if you keep the lab tabs open for too long, then they essentially time out and stop authenticating. So this has happened to me before as well. I'm pretty sure that it's like if you had trouble with like saving or utilizing those files because the lab authentication expired. So I recommend if you're going to be in the labs for a long time to periodically download the files or to just do it in Google Colab. Either way, it should be good. And then as Karen put here in the forum thread, this is the week 9 lounge. If you just right click on the file and go to download, this will work for both your notebooks as well as your images. You should be able to download those raw files, then organize on your local computer before uploading them into GitHub. Yes, George.
Yeah, I had the same issue. So I had Anaconda downloaded on my laptop, so I just created a new notebook and just did what I had to do over there. It is
Right.
not the frills or whatnot of the original notebook, but it has the code and everything, so that should be okay, right?
Yep, that should be totally fine. If you do the notebooks locally versus Google Colab versus the actual Jupyter Lab environment, any of those ways will work. So yeah, I actually run all the notebooks locally in my own personal Anaconda environment as well before these live sessions, just as a backup for the cloud environment. So yeah, personally, I don't mind either way as long as you're able to start running these notebooks.
Super. Thank you.
And I
Yeah,
think,
great question.
and I think follow what Alexander showed last week, and actually try to organize the files into directories and so on, and so we'll upload that whole directory structure to Git GitHub. Then you have
Yep.
something nice like on the top, so you look in the repository, the top level, maybe you see the README, and then maybe I'd say maybe have the presentation there, and then you write up there. And then within that have a directory like notebooks, and then put notebooks are in there. That's a little
Oh,
better organization. Do
yeah.
you
Or
think?
leave it up.
Yeah, I did all that. Everything's done except for the last capstone, so the presentation. So, but I'll organize it based on notebooks as well if you want it that way.
I highly
Yeah, I
just
mean,
recommend you can
it's just
organize it however
recommend.
you
It's
want.
nice. Don't worry about it too much for this. Um,
Yeah. Just one of the ideas is that you should be able to include this like on your resume, for example, when you talk about like prod data science projects that you've done. So you could also imagine like someone completely unfamiliar with you or your work, if they or us, if someone visits this repository, can they easily kind of see what you did, why you did it, and the results of your project, right? So maybe like
it's
an
no big, huge
employer or
for this.
yeah.
It's no huge sin if there's like just a flat directory structure in their GitHub and there's six files or something. That's no
I've
big huge sin.
Yeah, I've also seen this where it's like literally there's no folders and it's just like a million files just all
Yeah,
listed and
not a
it's like, oh
million
my
files,
God.
but
If I
six
was gonna
files.
hire, yeah, I
I
wouldn't hire you, but
I had
I'll still
I,
grade it.
Or alternatively, if people want to just do it flat with the six files, whatever, and then later at their convenience, they can reorganize it later if they want.
Yeah.
I'd
I have
rather see everybody get the work done than worry about those details.
I have it as I see it on the screen here, Alex and Karen.
Fair.
So
Yeah. Cool. All right. Last thing I want to say is beyond besides the notebooks, we then want to consolidate our capstone project into kind of final executive ready reports. So the deliverable that you have to do is a slide deck presentation. If you download the assignment presentation here, it'll download it as a PowerPoint, but you do not have to use Microsoft Office or Microsoft PowerPoint for this. For example, I do not pay for Microsoft Office. So what I did was I uploaded it to my Google Drive and then I opened it up in Google Slides. So this is totally fine as well if this is how you want to edit it. I know Karen also provided resources to a free version of Open Office, which will also work. Or if you pay for Microsoft Office, you can definitely just do it as a PowerPoint. The TLDR is I need you to go through these slides, which I think is about 50 slides or so, and just fill it in with the results of the capstone. So it's going to consolidate all your outputs from week 9 and week 10. So, for example, here we're obviously going to fill in your name and the date of the capstone. You could probably remove this slide as well. And then we'll go through some of the slides here. So I recommend like filling this out. You need a summary of your methodology, summary of your results. So it's like executive summary slide, introduction slide, and then methodology. Again, we don't like for too much, right? Just a quick like blurb about like what you did. You can like delete this or add as much as you want into it. Again, like, I'll leave it up to you to help design it. But this is some high level overview. I've seen students literally just fill in the blank. So fill this out and fill this out and fill this out. I've had students like completely redo the whole slide deck from scratch with their own themes to make it more SpaceXy and rockety. So like whatever you want to do, right? There's different ways you can organize it from like a bare minimum to a over the top. But either way, like there's you'll need to fill out these slides. A couple things I want to point out on the data collection slides. There's a mention here for providing flowcharts of the API calls and flowcharts of the web scraping. You do not have to make a flowchart. What I would want here instead is maybe like an image of the like SpaceX API documentation. So it wants to see this flowchart of available routes or something. So instead, like maybe we just take a screenshot of all these different routes or I've had people submit screenshots just of the like documentation, like API. Again, it doesn't really matter what image you put. It doesn't have to be a flowchart. And then just describe like, hey, for our project, we utilized, let me go find it. Which endpoints did we use? We used the launches endpoints, I'm pretty sure. We use rockets, launch pads, and payloads and cores. So you could just mention that you use those four endpoints. If you wanted to, you could even like do a screenshot of your code if you wanted. But again, don't feel like you have to go find a flowchart software. Like literally all we need is what were the API calls you made? And then same thing for the web scraping. You don't need a flow chart. All this wants to be is what did you scrape from the website? So what I would just recommend doing for that is going to the URL or even just taking this image, like this one, this table right here. That's what you scraped. So you can literally just take this image from Jupyter Notebooks, or you could go find the URL and go ahead and just take a screenshot of the table from this web page as well. It should load here in a sec. Yeah, there we go. So, yeah, take a screenshot of like this past launches table and call it a day. Again, it should be just not, doesn't have to be a flowchart. It just needs to be representative of what did you scrape from the second data vendor. Cool. I think that's the most important thing to call out on the slides. The rest of them are pretty straightforward. Again, try and add in as much context, visualizations, whatever you want to showcase on these slides. It's basically one slide per notebook. So this is going to be like 9.5. That's going to be 9.5. This will be 10.1 or 10.2 that we're about to do. This will be 10.2 that we're about to do. And then this will be the machine learning. And then same thing, these should be all the images you made in 9.4 and 9.5. These should be the same images that you made in like all the EDA notebooks and stuff and the tables. This should be the same maps that we make today. This should be the same dashboard we make today. So literally just copy and paste like some of your images in. And again, it doesn't have to be fully robust, but it's a way to consolidate the outputs of all your notebooks. That's the high level purpose, consolidate all your notebooks. So again, you have a lot of freedom with this. I don't really care if you restrict yourself to the template that we have here or if you kind of make your own. But what Karen and I are looking for is a consolidated slide deck that walks through the entire project from purpose and your story all the way through to your data extraction. What is your data vendors, your data transformations, your data loads into SQL, and then your EDA and your business reports and your machine learning. So just walk us through the whole project so you don't have to go through all the different notebooks. You can imagine the purpose of this would be that you have like a 60-minute presentation that you need to give to your data science manager about your project that you've done. So it's a little bit technical in scope, but it also needs to have the output like executive decision making, actionable insights and conclusions. Like what can we do as a next step? What are some like outcomes we can take from this project? So when you upload this, I want it as both PowerPoint and PDF, mostly because PDF renders inside of GitHub. So whether it's in Microsoft PowerPoint or Google Slides, you're going to go to File, Download as PowerPoint, and File, Download as PDF, and then upload the PDF and PowerPoint versions into your GitHub. The slide deck is required for the Capstone submission. This, I think, is like 50% of the grade is just the slide deck. Last thing that I would optionally recommend, but it's highly, highly recommended, would be to translate your slide deck into an analytics write-up. And if you're feeling stuck on time, you can literally just upload your slide deck into an AI tool and say, generate an analytics write-up from this, and it'll do it for you. But again, just make sure that you add in some like images and things into it. So for the analytics write-up, I added a link here on like what an analytics report usually looks like and how it's structured. So definitely read up on it. But basically, it's the exact same thing as your slide deck, except instead of having like some small blurbs, you have like paragraphs like describing kind of what you've done, right? So it doesn't have to be very long. Literally 2 pages is fine. And then you can include all your images and stuff as an appendix. But you want to just communicate what you did. So again, what's the purpose of the project? What the data sets you used? How did you extract, transform, load your data? What did you discover in your exploratory data analysis? What was the model that you built and its performance? What was the business report that you created and actual insights from it? And then try and include some of those graphs and visualizations in the report itself. So, and don't feel, to me, like it should be just an offshoot of your slide deck. Again, if you were giving this as a presentation to your technical manager, you would likely have a document that includes your speaking points and notes anyway. And again, that typically gets tracked with your analytics report. So again, I don't care if you do this in Microsoft or Google Docs or whatever, just try and upload it as a PDF. And then if you really want to go crazy, you can include a README file. So again, this is when people visit your repository and they've never seen your repository before. You can actually flesh out this README file, or an AI tool can do it for you as well, to describe the purpose of the project. So it makes it a really clean part of your portfolio. Just an example of what that could look like. If I go to some of my like old repositories here, you'll see that if I go to like one of these demos, you should, well, maybe not. I always choose that one and then it's never there. If I go to one of these demos, you'll see that I have a README file that describes the purpose of the project and all this good stuff and some of the results and things from it. So this means that if someone was just viewing this repository, they don't have to open up a PDF. They don't have to read like a full document. They can quickly just at a high level understand the purpose of the project and what it's useful for. Technically, including a write-up and including a README is optional, but since Karen and I grade the final projects, I would love to see one of those in your submission, and maybe we'll be more lenient with the grades if I see this optional but highly recommended written report. So yeah, TLDR, in your GitHub, you need all your notebooks and outputs. You need your PowerPoint as a PDF, and optionally, you need a write-up as a PDF. And then call it a day. I got 2 minutes. I want to go over timelines and important dates. So just in terms of timeline here, um, technically, Karen and I will be available in the forums until the 19th. Let me open this in a new tab. Oh my God, that's so tiny. Open image in new tab. Why are they so tiny? Let's just open this.
So we
Boom.
have engagement. We have the forum up until my birthday. Hand.
Yeah, there we go. So we'll be around until the 19th. The 19th is the official last day that they're going to shut down the course and everything, and then everyone's off for the last 2 weeks of the year. So in terms of how this affects you, obviously this is our last structured live session today on the 8th. We'll host an optional office hour on the 15th. And then it's recommended to finish the week 10 content, such as the notebooks, by the end of this week, like you normally would for any normal week. So by the 11th, 12th. And then that gives you this weekend to get your GitHub presentation, slide deck, and everything in order. The last day that is good for Karen and I for you to submit your GitHub link through the course is December 16th. Preferably, you've submitted it beforehand. We're going to open up submissions starting tomorrow. So if you've just done and knocked it out, I want to be done with this class. I cannot blame you. Then feel free to submit earlier in the week, and Karen and I will grade those on a rolling basis. But your last day to submit is the 16th. If you do submit it on the 17th, be sure to tag someone in the forums so we know to grade it. Karen and I are going to be wrapping up grading on the 17th, and then the system needs 48 hours to confirm grades. So they're going to confirm the grades by end of day on the 19th. Note that if you submit your capstone submission after the 17th, there's no guarantee that it'll be done and graded by the 19th. And then the 18th, I'm leaving open as your final day if you have any questions about your grades. Karen and I have full control over the grade book. So if you have any questions about the grades, just reach out to one of us or just mention like, hey, Alexander, can you look at this quiz or this capstone? And we'll be happy to kind of fix those grades as needed. So the 18th, I'm leaving up as like, let me know if there's anything weird in your grades and I'll fix them. And then, like I said, the 19th, everything is locked and sent back out, and you should get your certificate a couple weeks after that, probably sometime in January if I had to expect, just because everything's shut down the last 2 weeks. All of that is listed here. Try and complete week 10 by the end of the week. Submit your GitHub through the Capstone submission by the 16th. Hopefully, you do that earlier. Earlier, the better. We'll submit our grades by end of day on the 17th, and then that leaves the 18th for any last minute questions. And then the 19th grades are finalized, and that's our last day in the forums, and then we're out of here. So pretty fun over the last 2 weeks. Only other questions that I've got is the forum, like participation in forum posts. Technically, responding to the discussion forums is also optional, but again, highly recommended. So if you want to participate in those discussion forums, you have all the way until the end of December 19th, and Karen and I will read and respond to those. And I think that's it. Otherwise, I think the other grades are just kind of the end of module quizzes, right? So there's not too much. I think most of the grades for the whole course is this capstone project. So should be good. And yeah, maybe next Monday I will host like a structured office hours where even if some of y'all don't come with too many questions, I'll walk you through maybe some. There's some stuff in the machine learning that I wanted to go more in depth on, so maybe I'll talk about some of that. But I'll put some details on that in on the forums after we decide it. Cool. Miss anything? Questions? You know what we're doing for the capstone. You know how to submit it. You know the timeline on when to get everything done by. Cool. If this timeline doesn't work for you for any reason, please reach out to your student success manager. Just because since everything shuts down starting on the 20th through the new year, um, I just recommend getting everything done by the 19th. If you need an extension, then they'll probably give it to you. But note that Karen and I are pretty hands off after the 19th as well. So you'll have to go through your student success manager to get everything graded and submitted. Long story short, submit everything on time so we can enjoy the holidays. Anything else on your end, Karen? Or we'll dive into content here for the last hour.
Oh, it sounds good.
Sweet.
Other than saying, we could put up our PayPal accounts, just saying. No, just kidding.
Yeah. Good stuff. Um, yeah, I think originally I had on here to submit everything by the 17th, but then Karen was like, what if all the class, there's like 20 of y'all, even if only a few of y'all are active in the forums and stuff. There's like 20 of y'all. So if all of you submit on the 17th, then we won't be able to grade them all in time. So try and submit earlier the better, preferably over the range of the 9th to the 16th. And if you want us to review or look at anything first, if you submit early and we give you grades and feedback on it, and it's not the 16th or 17th, I have no problems if you update anything and resubmit or just let me and Karen know, and I'm more than happy to update your grades. So that's more incentive to, again, submit early so you can make any changes if you want to before the grades are submitted. Cool. All right, last hour here. Let me dive into some of the week 10 content. We're gonna start with the maps. So it took me a couple hours to do everything in week 10, and mostly it wasn't like too complicated. Mostly I just got hung up in trying to make these graphs look nice and then make the dashboard look a little bit nice. I know Karen was doing the same thing as she was working through like the adding the bar plots and stuff. And then we'll go some of the machine learning. So we'll do as much as we can in the hour that we have. But definitely I recommend again taking 4 to 6 hours of your own time over the course of this week to do it. One other reason why I like week module 10 versus module 9 is that it's a lot more copy paste from past activities. So when we make these maps, when we make this Plotly dashboard, this is going to be very similar to what you did in like week 6. So it's going to be a lot of copy paste from that. And then same thing with the machine learning, that's going to be very copy paste from what you did in weeks 7 and 8. All right, so let's start with the first interactive notebook here, which will be 10.1.3. The purpose of this notebook in this lab is to build some interactive Folium maps to kind of visualize our data sets. So I'm going to hopefully run all this in the lab environment and hopefully everything works. And then, yeah, as it said, I think it links to like past labs and stuff. So generating maps in Python. I think this is all coming from week 6. So note that this right here, you don't have to fill in any code. Let me just confirm that. Um, I think it just says task 1, we want to make a map. Yeah, cool. So here we're going to make a map. So let's go fetch our data from the cloud, and then we're going to just isolate the columns that we care about. And here is our beautiful data set. If we wanted to look at this a little bit more, we can do a .info on it, and we see that we have just 4 rows. I guess there's only 4 launch sites, and latitude and longitude are numeric. And I guess that looks good to me. And so what we want to do is visualize these launch locations on an interactive map. So to do that, we're going to utilize Folium. And here we have the latitude and longitude of the NASA Johnson Space Center. We're just using this as like a center point for the map of where we're going to start looking at. And here we're then going to build a circle on top of that Johnson Space Center. And this is just like, again, like hello world to test to make sure that we can create a map. And so this happened to me even on my local machine. Like make this notebook trusted to load map. What I recommend doing in this case is actually where did I mention this? I was in one of the module forums here. You can actually save off the maps. I forget where I said it. It's in one of the forum threads. But basically, if you where do I save the map? Yeah, there we go. If you save the map instead when you're supposed to be viewing it, so for example, I add in this line right here, sitemap.save sitemap.html. If I open this up, it should show me the map. There we go. Trust HTML. There we go. That's what I had to say. So now we can see that I have my little Johnson Space Center circle right here and the pop-up works. So and all I did for that was added this line to save the HTML, double clicked it to open up in my notebook, and then clicked this trust HTML in the top left. And so that should work to be able to interact with your Folium maps. Next, what it wants us to do is add in a circle and little marker pop-up for all of the launch sites that we have in our data frame. So again, I'm just going to rip this from my activity that I did earlier. Again, definitely recommend writing this out on your own. But essentially all I did here was add a for loop. For each, let me just give some of these extra comments. For each row in my data frame, grab the launch site text, the latitude, and the longitude. We're then going to make a Folium circle on that coordinate, and then we're going to add in all of that code. Again, I think I just copied it from the one above. So if we run this and then reopen the HTML, if all goes well, hopefully that works. Yeah, there we go. So all I had to do there was I closed the tab and then reopened it. So now we can see that there is my launch site in California. And then if I zoom in Florida, there should be 2 more here. Or there's 3 here in Florida. 1 here and then 2 more that are kind of overlapping. Cool. And that should match this little graph down here. Next, it wants us to mark the success and failed launches. Again, no code here. This is just the purpose of this. And if I was actually in this notebook, I would change this to be a markdown cell, but whatever. Task number two, let's try to make our map a little bit better. Not only do we have the launches and the latitude and longitude, we also have whether or not the launch was successful with a 1 or a 0. This means that we can now basically apply some custom logic here to basically color code in how many launches we had at specific launch sites, and then which of those launches were successful or failures. So to do that, we're going to use a marker cluster. It's exactly what it sounds like. It's a way that we can have multiple markers on the same location. So, for example, for this launch site, we need 1, 2, 3, 4, 5, 6, 7 markers, but they're all going to have the same latitude, longitude. So to put those 7 markers on the same latitude, longitude, we're going to do it using a cluster so that when we zoom in, they'll actually burst out. So you can kind of see it'll look something like this. We have 10 launches, we have 46 launches, and when we zoom in or click on them, they actually all burst out. So we can see here's the 7 launches, 1, 2, 3, 4, 5, 6, 7 at this launch site. Notice they're all on the same latitude, longitude, but we've also color coded them with green and red. Um, Again, it's not too bad if you go back to some of the old examples we did in class. For me, I definitely spent way too long trying to make this look nice, and mine looks really ugly, but I'll walk you through what we did. So first, I added a new column to the table or to the data frame, and that's what this wants you to do right here. Create a new column in the data frame called marker color. So I'm going to plop this in here. Basically, it's just a for loop. I did an apply, but you could just do this with a for loop. If X is 1, then green, else red. And if you want to see what that looks like, you should be able to see that these are all failures, so I want them to be red. Now we can loop through the data frame. For each data frame, we're going to create a marker and then add it to our marker cluster group. And then we will save off the HTML again and view it in our notebook. So again, here's one I made earlier. Yeah, I don't think I needed that. I don't know why I added that one in. I think it's just this little for loop right here that we need. For index and record in my data frame, we're going to grab the text, grab the coordinates, create a marker. Notice here that I'm using this color marker color to utilize that column that we just did. And if all goes well, this should make a new marker cluster and hopefully should update my map. Update the map, trust the HTML again. Ooh, we do have marker clusters now. So if I zoom in over here, we'll see this 46 should break out 1333. And if I zoom in more, this 33 should also break out into 26 and 7. And then if I click on this 7, I should have um, my little launches here. I know it doesn't look exactly as nice as this, so I'll leave it as an exercise for the reader or an exercise for Karen to figure out how to make my my markers look nicer than this. Again, I'm not getting graded. I'm the instructor,
I
so I don't have to make it look
I
super
already
pretty.
got it.
Did you? I
Yeah.
was like, I couldn't figure out how to get the marker icon in the back. You can just like me the code afterwards.
Oh,
We'll
yeah.
put it in the forum. I got a lot to go through in the next 45 minutes. But again, like this is where you can lose some time just again fiddling with it. There's no right or wrong answer here and how you design it. But again, here's how I did it. Karen's going to slack out how they did it. And again, hopefully you make something look nice. The last part to the interactive map project is to look for distances to bodies of water, train tracks, and water, and like roads, which is pretty interesting, honestly. The idea that what we're trying to add is are these launch sites close to transport services? Again, this cell should be just a header. And then what we're going to do here is Basically, they've added this mouse over function. And yeah, whenever you see a publish for sitemap, I recommend just saving it off instead. So we're just gonna add in this line over here. Basically, when we mouse over anything on the map, we should be able to then like get the latitude and longitude of it. So let's see if this works. I actually didn't try this locally. I actually don't know how this is supposed to work. It's in the top right. That's pretty cool. So as I'm zooming in, basically if I hover over something, yeah, like the water, it'll tell me the latitude, longitude of where my mouse is. That's pretty cool. Sweet. Cool. So let's go back to the notebook because that's kind of irrelevant. But now what we're going to do here is given a location, we're going to calculate distance. And you can get really nerdy with this, by the way. I'm just going to go on a small tangent. So when you calculate distance, there's a lot of different ways to calculate distance. So for example, a lot of us know Euclidean distance, which is straight line distance or as the crow flies. This is your classic distance formula x1 plus x2 squared minus y1 plus y2 squared, whatever it is. However, when you talk about the Earth, because it's a sphere or a spheroid, calculating distance can actually be a little bit different. So I think that's what it's doing here. It's doing some crazy stuff with radians. Basically, what it's trying to do is something called great circle distance which I love. I think this is really interesting. Basically, it's how do you measure the distance between 2 points on a curve or on a sphere. So this is called great circle distance, and it's actually included in like NumPy. I'm pretty sure NumPy can do it. So I don't know why they created a its own Haversine. Yeah, there you go, Haversine distance. So there's different ways to do and calculate oh, like yeah, scikit-learn's even got a handy function called haversine distance for this. So there's a lot of different ways to do it, but just note that calculating distance on a sphere is not always super easy and straightforward. So they gave us a handy dandy function to use to calculate the distance between 2 points on a globe. And then from there, basically, it wants us to mark down a point using the coastline and the launch site. I don't even know if I actually did this in my own notebook. Oh, I did.
I did
Uh,
like
f-
I did like one on each coast.
yeah, I like found one here. I think I asked Cursor to do it for me because I'm like I'm fed up with this. But yeah, it's here we're just finding the closest coastline and then we can run it through our handy dandy function. And again, just using these example points that it gave us, we can see that the coastline is half of a kilometer away, which is really interesting. I think what they want you to do is use the mouse position. So as we're hovering over the like coast here, what they want you to do is if I hover over like the coastline, use the latitude. You can't see my finger, but I'm pointing to the top of my screen. I want to use like 28,562 and -80 which is pretty close to what these numbers are. So yeah, no one's going to yell at you if you just use those numbers. And then what I want us to do is draw a marker on our graph. So let's go ahead and add that and then save off our map again. We need to close the HTML, reopen it, trust it, and if all goes well, if I zoom in far enough, oh, there it is. There's that zero half a kilometer marker right here, the 0.58 kilometers. Success. Last thing we want to do is draw this straight line between our points. And again, that's pretty straightforward as well. And all we're doing here is defining the coordinates. So we have the launch site coordinates and then the coastline coordinates. And then we're going to draw a line using kind of that starter code. And if all goes well, we should get a line. And again, if we zoom in far enough, look at that beautiful blue line that we did. from our launch pad to our thing. Again, I apparently I used the wrong latitude longitude because this is definitely not the coastline. So definitely on your own project, do this better than me and actually have it draw all the way to the coastline. So I guess I'll know if you just copy and rip from the solution that I put out. Last thing I want you to do is do the same thing for a railroad or a highway or a city. Again, I think I got a little bit fed up here, so I just grabbed some. I think these are random ones. Again, I just asked Cursor to do it. So again, same idea. Definitely spend more time on this than I did. But go ahead and try and find a railway, a city, and a highway. And then you're going to draw all your lines. And then if all goes well, if I open up my map again, trust the HTML and zoom in, I should see a lot of lines. So like here's the distance to the road, here's the distance to the railway. Looks like it actually did get it right. And then like here's the distance to the city. Maybe I did spend a little bit more time on this than I thought. Hit Titusville. Look at that. So I think the only one that I actually didn't do properly was the coastline. I think yeah, that's supposed to be the road. Cool. So that's kind of the part here. You're building this interactive maps. Try and kind of fill out some of these things again. Like your findings are, wow, shocker, launch sites are close to highways and railroads and coastlines. And wow, launch sites are far away from cities. Like, great. Common sense stuff, but again, it's pretty cool to be able to see that on the map itself. Cool. So yeah, what I would download for your repository here, definitely you need to download the notebook. So again, once everything is saved, you should, I want to file save all for that, but I can also save them here. You then go to right click download and then right click download. And then if you want to see how I'm organizing things under live session, maybe we'll create a new folder for, I guess, 10.2.1, I guess. And then we can shove in these documents. And then you'll see it'll be really easy to then upload those to GitHub if I wanted to. All right. Cool. So again, you have freedom here as well. You can change the colors, spend some time with the labels, spend some time with the icons, spend some time with your polylines. Start if you have like if you're like me and you question everything, start figuring out like what the heck is this? Again, it's great. It's not Euclidean distance. If you actually look at the distance formula, it's like a crazy one, but it's actually Haversine distance, which is great circle distance, which is distance on a sphere, which is pretty interesting. So definitely you can research some of that or call it out in your final slide deck. And then these are going to be the images that you're going to take screenshots of for your deck. If I go to some of the Folium expectations here, yeah, I want you to basically look at it in three different ways. You want it's three different screenshots. So it wants kind of the US screenshot. So the first one would just be looking at this like full map, take a screenshot of this. The second one that I want is the color-coded outcomes. So zoom in on one of your launch sites, and then it wants you to take a screenshot of this, the green and the red, and then the third one is the lines. So zoom out a little bit and try and get your lines on the map. Maybe, yeah, there you go, Titusville. Maybe screenshot something like this, and then you can call out you've got the distance to the city and the distance to the railroad. And then you can add in like more than one screenshot or more than one slide. You don't feel like you have to be restricted by the template. You can definitely add more or less depending on what you're trying to communicate. All right, we got to fly. The dashboard is actually fairly easy. Yeah, if you have questions, please put your questions in the Zoom chat so Karen can answer them. But I'll try and get to them live after I finish reviewing some of this stuff. All right, second half. I'm gonna close this out now that I've downloaded them. Second half of the interactive dashboarding is going to be 10.1.4. Oh yeah, so this is definitely not the right folder name. 10.1.3. All right, so in this version, in this part of the project, our task is to build out a Plotly dashboard using Dash. And again, this is going to be very similar to what you did in week 6. Let me just double check to see what it wants on the screenshots. The pie chart, and then so the screenshot of the launch success count, the with the highest success ratio. Okay, so you can build the whole dashboard first and then just take some screenshots. So there's again, you have some freedom here as well. It gives you the tasks of what it wants you to do, and it gives you a little bit of starter code. So I'm just gonna go walk through how to set this up, just because I want you to make sure you know how to walk yourselves through this. So remember on the left, this is a little bit different of an interface for the Plotly Dash. These are going to be .py files, not notebooks. So we're going to execute them in a more, we're not going to be using a notebook UI. We're going to be using this Visual Studio like IDE. So what we're going to do here, if we click on the two pieces of paper, that should take us to our File Explorer. And what it wants us to do is to first open up a terminal and then run. Yeah, that's the skeleton one that we want. So once it's opened up a terminal, so now that I've clicked on this Explorer, I'm going to click on Terminal and then New Terminal. And then it gave me the options to execute here. So I'm going to copy this line. This is our pip installs, and this should just work. So we'll let that work here for a minute. And then what it's going to do is it's going to download the data set, which is this CSV. And if I execute that, you should magic, we have our CSV shown up here. And if I click on it, you can actually see what it looks like. So again, this is the same data set that we worked on in module 9 and in the last notebook as well. And the last thing we're going to do is download our Dash app as well. So if you're going to work on this locally, if you want to use Cursor or VS Code, that's totally fine by me. Just know that you need to download these. So again, same thing. If I right click on the CSV, I can go to download and that should download the CSV. And then same thing for the unsolved skeleton Dash app. So like what I did is I downloaded these and then I opened it up in like Cursor. But you can either edit them inside of this IDE or you can download them locally, whichever you want to do. If you work on them inside the IDE, note that once you're done, you'll still need to download it for your GitHub. So download it here again, just to make sure you have a copy of it. All right, to run the app, if I copy this command and paste it into my terminal, this will launch the app on port 8050. And remember to access the port, we have to click on the Skills Network Toolbox icon and then this launch application. And we're in 8050. And that should open up a new tab. And obviously, we haven't written anything here, so we have a couple of blank empty dashboards. Again, I want to give you enough freedom to kind of work on this on your own. But if you check my GitHub, and I'll bring like the solved example over here so we can jump to the machine learning. If you check my GitHub, both Karen and I did like independent solutions for this. So mine is more applicable to what the expectations are, where you add this drop-down list, where we loop through all the sites and then create a drop-down value. We create our pie charts using a slider and stuff. And then we add in our callback function so we can interact with the pie charts, right? And then from there, we create a scatter chart for task number 4. I'd probably like Karen's a little bit better because, again, I just kind of threw mine into Cursor and said, like, have fun with it. I think it's ours are pretty close. Okay, yeah, I was going through Karen's now too. Add in the drop down. Oh, you just did it. You hard coded them. This works good too. I like it. And then create the pie chart. We're doing that the same way. Callback function. If it's all, you have one pie chart with everything. Else, you have the different launch sites. Love it, love it. And then I think you did the bar chart, right? Yeah, Plotly bar chart. There you go. Find the rows that make it a bar chart. So there's a couple different options here. Again, if you were to spend time on this more than Karen and I, it'd probably take you an hour and a half, 2 hours just for the dashboard. So keep that in the back of your mind as you're working through this as well. I do expect it to look a little bit nicer. I'm gonna steal Karen's because I think it looks pretty good. So here's one option. I'm just gonna paste it in and save it. And now if I go back to what this should look like, if I refresh it, or I guess let me kill it and then rerun it. So to kill it, I did Command C or Control C and then up arrow, and that should rerun the app. And then we can relaunch the app once it says it's moving. 8050. Beautiful. I think we actually open this up in a new URL. Yeah, there it goes. So I just clicked this little icon up here on the top right, which opened it up in a new browser tab. So here is kind of an example of what this dashboard would look like. We can filter it by the different landing launch sites, and everything should change, hopefully. And cool. And here's the little, they did a bar chart here. I did a scatter plot on mine. Doesn't really matter, however you want it to look like. And again, you can update these colors, you can update the header, like try and be a little bit creative with it, right? Like you can make it your own. I'm not looking for like a copy paste of what Karen and I do on this. So kind of work through it on your own, make it look nice. And then yeah, for the slides, it wants first one, show the screenshot off the pie chart for all sites. So that would just be with the all sites enabled. They want a screenshot of this pie chart. The second one, screenshot the pie chart with the highest launch success rate. So for example, this one's 73. Oh wait, no, 26%. This one is 43%. This one is 77%, and this one is 40%. So it wants you to do the KSC one and show that this is 77%. And then this one, it wants the scatter plot or the bar chart. Again, we're not going to grade points off if you do a bar chart. So do whichever one floats your
I
boat.
just I just thought the scatter plot was just next to impossible to read anything from.
It was, yeah, I couldn't read
And
it.
but also notice I kind of got a little picky and made sure that failure is red and blue
Yeah,
success. The examples they showed are reversed, and to me that was like silly, counterintuitive, and not
yeah.
good plot design.
I guess there's also one the booster. Is yours on the, do you have the booster? Oh, booster version. Yeah, you added them there.
Yeah, I
Yeah, so
rearranged it so that you could actually learn something more quickly from it, from that.
yeah, because this is so hard
I,
to read. Yeah, the
I
zero is
I have a
failure, one is
total
success.
I have a total aversion to using scatter plots with categorical variables.
Yeah.
And if you have a
Let
lot of
me.
data, they become impossible, though you can apply jitter to kind of spread them out a little bit. Or you might notice if you use the Seaborn cat plot, it does a nice job of kind of jittering categorical
Yeah,
things in a scatter plot so that you can actually kind of make some sense of it.
let me show. So mine, I actually did the scatter plot in my version, and I'll show you all quickly what it looks like. And yeah, Karen's exactly right. It's really difficult to read exactly what it's actually trying to visualize.
Yeah, I tried also changing the axis so that it was so
Yeah.
the y-axis would be the booster versions and then the coloration would just be success or failure. But even that didn't look so great to me.
So the reason why all the scatter plots are the dots are on 0 and 1. 0 is a failure. So all these dots are failures, and this one is successes. And then it's color coded by booster version. And we have payload, some for some reason down here as well. So this is like really difficult to read. But if you want to walk through the code, it's not too different than the bar chart.
Uh,
Basically, it's still the exact same data that you have to get, and then it's either do you use px.bar or px.scatter to make the visual. But yeah,
one,
we're not going to kind of point either way, but no, there's multiple different ways to visualize and tell this story.
no, I'm confused because I assumed that class 0 and 1, 0 would be failure and 1 would be success.
It is, right? Isn't zero failure?
I would think so.
Oh, no,
Yeah.
zero success. Wait, now
Well,
I'm
no,
confused.
they had the coloring wrong.
Oh, yeah,
They
so
showed
one
failure
here
as
is,
blue and red and success as red, which to me is counterintuitive. That's why I changed it
it's,
in mine.
I guess that's weird that's happening for some of these.
Well, it
Yeah,
just
so
did in
definitely
the
sp
order. It just did in the order, just colored zeros first with blue, it starts with blue and then goes to red. So,
Gotcha. Yeah, definitely again, Spence, just like with the other visualizations, like it takes that we talked about this in week 6, but it's really nice that the creative design aspect can like comes through in data science. So definitely try and spend some time on these dashboards, on these reports, try and make them consistent. If what Karen and I are discussing is going over your head because you haven't got this far yet, like that's totally fine. But try and see where we're coming from. Like, hey, why is this a confusing graph? Why is this confusing in its color assignments? Right? Like, how is an end user, how is your grandmother supposed to use this to find information? If you and I, as technical people, can't even use it to find information, right? So just think about some of those things as you start building these out. And again, I would challenge you either in the next week or so to spend time both on the interactive dashboard as well as the Folio maps to try and make these actually represent business ready consumable reporting data products. All right, I don't have too much time left, so I will also download this here. And so we've walked through what I expect you to create here and how to translate those over to your final slide deck. So same thing. When you download it, I expect you to download the CSV file as well as your final app. So again, I'm going to include 3 versions of the app here. The first is like the unsolved, and then the one of them is like bar charts, and one of them is the scatter plot. You don't have to like have 3 different versions, but I do need one version of your dashboard and your CSV in your GitHub. So again, just download those from the lab environment, and then you should be able to upload it to your GitHub as needed. All right, cool. We got one last thing to hit on. 20 minutes. We should be pretty good on time here. I'm gonna close this out and cancel it. All right, the last one is the machine learning section, which is fun. That's obviously kind of my favorite parts of the class here. The machine learning one, there's not too much craziness in there. Um, Mostly, again, you need time to spend on it to do it right. It's not as thorough as I want it to be. You'll notice that we actually don't create like training pipelines or anything, which was kind of disappointing. But at a high level, what I want you to explore in this specific notebook is cross-validation and grid search, right? So remember, those are aspects we introduced last week. Grid search takes, once you've figured out what algorithm you want to use, such as like a random forest classifier, you'll notice that these algorithms, as you expand beyond like logistic regression and linear regression, they have different parameters that we can use, right? How many trees do I want in the forest? How deep do I want the trees to grow? How do I want to kind of like work through some of these other parameters? So what a grid search does is exactly what it sounds like. It'll generate many different versions of the model. So every combination and permutation that you specify, it'll train all those versions of the model, and then it'll tell you which parameter performed best. So that's the purpose of grid search. And then combine that with this idea of cross validation. Cross validation basically solves the bias problem of a train test split. When we use a train test split, by definition, we withhold 20% of the data and train on the other 80%. However, you could always get lucky with how your train test split works. So what cross-validation does is that it'll use every point in your training set as both training and testing data. So basically, it'll divide your data up into five slices, and then it'll use four of those slices to train and one to test. And then it'll do that for every combination of slices. So cross-validation and grid search should hopefully give us a much more robust and trustworthy model that we're more confident in how it'll perform in the real world. Further, we want to also incorporate more of the evaluation sections that we talked about last week as well for classification models. So let's go ahead and we'll knock this out inside of this. I'm going to go through what it wants you to do first, and then we'll add in some extra stuff at the bottom because I also recommend doing a random forest and XGBoost classifier as well. And again, you can ignore all these warnings and things. Cool. So we have a function here to plot a confusion matrix for us. Did we also load in a classification report? Where's their
It
metrics?
doesn't offer it. I mean, it doesn't ask for it, but I think it's a great idea. I mean, and it doesn't take they don't even import it.
Mhm. I'll
But
do that real quick.
if you want to add it, I think it's a
Uh,
nice touch.
yeah, because I was gonna say I thought that was a scalar and had its own function for plotting a confusion matrix. I'm gonna get sidetracked again. Yeah, there definitely has its own function. Confusion, maybe, yeah, plot.
Oh,
There's already a function to do
oh, I
this,
didn't know
or
there was
maybe
one.
it's like confusion matrix display or something.
Oh,
So that's
cool.
kind of funny.
So
Yeah,
it kind of
whatever.
just does it. So instead of
Yeah. But I'm gonna load in classification reports. I'm also gonna load in rock aux score. All right. Uh, cool. So let's load in our data sets. And here is our, we've already pre-processed it. I guess that's why they don't do a pipeline because we've already got the one hot encoder done. I probably would have done a scalar on payload mass, but it's probably fine. Cool. What it wants us to do is to make our target, which is going to be Y. It wants it to be a NumPy array just to make it a little bit easier to train our model on. And again, there's different ways that you can do this as well. You don't have to use NumPy all the time for this. But yeah, here we go. Y equals data class to NumPy. And if you're curious what Y looks like, it looks like that. And if you're also curious what X looks like, we have 90 rows. So that's going to be something that you should call out immediately, that we don't have a lot of data here to train our model. We only have 90 rows of data. So we don't have a lot of data. Oh, there we are. There's our standard scalar. Um, what we're going to do here is we're going to do our train test split. Oh, we forgot to reassign it. So I guess we're scaling our entire data frame. So usually you wouldn't do this either. Mostly like all of these one hot encoded dummy variables, you shouldn't run them through a scalar. And we talked about that in week 7 and 8. Your numeric features should go through a scalar, and your categorical features should go through an encoder, but those should be separate steps in a pipeline. But I guess we're ignoring that in this case. Exercise for the reader, I guess. Go back and grab the unencoded data and do it properly. But I think that's out of scope for the purpose of this notebook for the capstone. Again, if you think about it, the purpose of what this notebook should reiterate to you is grid search and hyperparameter search, and using those grid search and cross validation, and then adding those into your machine learning toolbox. Let's run our train test splits, and we should see that we only have 18 rows in our test set, which is not very many at all. So we don't really have enough sample size here, but again, ignore that for now. Now we're going to train a whole bunch of models. The first one that we're going to do is a logistic regression. Notice that we are giving it a couple of items to tune. And if you're curious, you can always go to the documentation and you'll see that this C parameter actually represents the regularization strength. So that is what we're going to try out here. We're going to try three different values of the regularization strength. And then from there, we should be able to fit our model. Am I on task 4 here? Oh yeah, grid search, CV. There we go. So that should work. Notice it just trained a whole bunch of different models here. I don't know why I use CV10. That's probably too high. I'm gonna change this to 5. That's like the number of folds it wants you to use. You probably only need to use 5 folds here, just because again we have a really small data set. And if we look at our model, the best hyperparameters, a little bit of a typo there, was C equals 1, and it had an accuracy of 819. And if you're curious, we should then also be able to get our rock awk score. Oh, we'll do that on the next one. Calculate the accuracy on the test data. So to do that, we're gonna do this X test, Y test. And then we had a 83 accuracy score. And if we get our confusion matrix, it should look like this. So that's all fine. But again, because we only had 18 rows, this basically says we were able to perfectly predict if a rocket will land, but we had a pretty rough 50-50 chance on if a rocket failed. We weren't very good at predicting that. But we should be able to print our rock awk score of y test y hat. Where's y hat? Oh, y hat no underscore. Oh my God. And we can also print the classification report of y test and y hat. Oh my God, I gave it an underscore again. Cool. So that's what I want to look at here. We have this 83% accuracy, and then we only had a 50% recall on whether or not our stage failed or not. So yeah, we see the main problem here is false positives. We had 3 false positives, which is why we had such a harsh recall. All right, so let's try this for a few other models. We got a couple more that we're going to do here. So support vector machine. Again, this is a very complex linear model. It'll still create an equation, but it should be able to capture nonlinear effects, but it's still a linear model. So it's going to be a support vector classifier. Let's go ahead and do our grid search on it. Again, for the sake of this example, I'm only going to use a CV of 5 because I think 10 is way overkill, um, especially for such a small data set. SVC as well as a more complicated model. So it takes a little bit longer to train them all. And we can see how many permutations we're training. 1, 2, 3, 4 times, like all of those different options as well. So this may take a minute to run. I should have skipped this support vector machine. I knew it took a long time. Oh my God. While that's going, I'll just fill in the rest of this code just
Did
so it
you
can
change
run.
the kernel
Huh?
on the? Did you change the kernel on the? That's
No, that's the decision tree. Well, that's no, it
oh,
should it just there's just a lot here
yeah,
to
it
go
took me no
through.
time at all. It took me no at all though.
Oh, really? So I'm crashing my kernel. Is that
I
what
don't
what
know.
it's
It
doing?
took me no time at all. I
Oh,
was
well.
surprised how fast it was. I'm used to grid searches, like you start it and go to bed, and in the morning it's ready.
Yeah. I hope I didn't crash my kernel.
I'm just changing my opinion about a few things here. I really think we should be dropping flight number, and we'll probably end up not doing so good because
Yeah,
really the truth is that early flights failed more often because they were still developing the technology.
yes, I agree.
So in a sense, technically speaking, including flight number could constitute a form of data leakage as a result.
Yeah. I don't think they needed yeah, I agree with that.
Oh, I'm yeah, disappointed. They spent everyone doing time on EDA and then they didn't apply any EDA to actually feature
Yeah,
selection.
to the yeah.
Then they just throw
All right,
everything, just like that
let me
cartoon, they just throw everything in the pile and see what happens. I'm opinionated, I am.
no, I just want my okay, we're running again. Um I think I'll skip that support vector machine one. But one thing you'll see is that
Oh,
support vector machines should outperform, or I should try it again. You think it'll be quick?
I basically got the same performance on all the models, and that's because there's too little data.
All right, we'll try and run it again. Oh yeah, there it goes. That's quick. So yeah, what you should see here is that the accuracy should be a little bit better than the logistic regression. So this 834 is definitely better than this 83428. I guess I got basically the same number. I got a little bit better than mine on my data set, but maybe there's some randomness involved here. But anyway, if we score it, it's the exact same, and the confusion matrix is the exact same. So that's why I also recommend looking at the rock score and the rook score and the classification report as well. But I think it all turns out to be basically the same here. So because we only have 18 rows, it's going to be pretty difficult to change it up. All right, I got a couple more I want to do before we run out of time. So, decision tree. One thing to note is that this auto for max features is no longer a thing. Instead, you need to change auto to log two. Is that right? Let me check. Yeah, log two for the decision tree here. And then the rest of this should be same copy paste that we've been doing. So let's go ahead and fit our grid search. And this is going to train like 6,000 different models, which is kind of crazy. Oh man, let me stop that again. No, shoot. I wanted to only do five. Maybe that's why my support vector machine did. I'm gonna do five here instead. Let's see if that works. Oh, maybe that didn't work. I should have restarted. There we go. And then we can see how good our decision tree is. And look at that. Our accuracy on the testing set has gone up to 8.8. We can see our best hyperparameters grow the trees up to 4, and max features of squirt, and our I'm surprised they didn't do like n estimators, but whatever. Check how good our model is using the best score. And on the test set, it's going to be the exact same as the other ones. Oh, we're a little bit worse, actually. And maybe we're overfitting a little bit. Plot the confusion thing. Yeah, so it looks like we're way overfitting. And we predict everything to land all the time, which isn't great. So that's good. We made a worse model. When I did on my own local one, I guess it had the same result. So yeah, we basically predict all the rockets to successfully launch, even if they don't So that's not a great model. Last one here is KNN. Let's go through and train our KNN grid search. Again, same dealio. I'm going to use CV equals 5 here, but you can use 10 if you want. And this had a model. Oh, we're well on time. 125 or 225. Our accuracy here was 8.6, and then we can see how good it was on the test set. We can make the confusion matrix, and then we can do the same rock score and classification report. And I want you to pick the model that performed the best. Looks like KNN. I would probably pick KNN or logistic regression. I think they're all basically the same on the test set, but the KNN was slightly better on the training data, which either means it's overfitting or it was just a slightly better model. So KNN maybe, or logistic, but not enough data to be, not enough training data to be confident in either. That would be my conclusions. And then for bonus, I recommend doing this with
Good.
Random Forest and XGBoost, which I'm just gonna do real quick. So yeah, let me load in. I did it for these guys. Let's hope that this works. I'm not okay, thank goodness XGBoost was in there. Let's do our random forest. This for random forest. I'm also tuning the number of trees in the forest. Oh, that's why that's not a thing on decision tree. But yeah, that'll be a thing for random forests. And I'm also doing 5-fold cross validation. I could also do log 2 for max features, but I'm not for the sake of time. And then let me load in my other kind of cells here. So let's look at the performance of it, as well as the score and the confusion matrix. And then same dealio, let's grab over the rock score and the classification reports.
Oh, come on.
Go on, Random Forest, I believe in you. Hopefully that wraps up here in a sec. And then you can also do the same thing for XGBoost. Same dealio, throw in some XGBoost parameters, and then it's just a copy paste from all the other cells. Show the accuracy of the XGBoost model, and then we're going to show the score of the XGBoost model and the classification or confusion matrix. And then we're going to print the score. And let's take us to the end. This may not finish. And oh, there we go. Thank goodness. Hyperparameters. So this is interesting. More trees in the forest. 200 trees actually perform the best. This 847 is worse than KNN, but higher than the logistic regression. And that's just for the training set. On the test set, we had the exact same results on the test set. If I had to use, I wonder if I could have used the probabilities instead, because Y hat, it's just doing the predict. So if I do predict proba, I wonder if there's a way to do that. Maybe they're supposed to use predict proba.
Yes, for that you need, I think you do need that.
It is supposed to be predict proba. So I need to go back and update that. I'll do that after class. Because I was like, the rock score should be changing for all of these. Let me kick off the XGBoost parameters. I wonder if I did that on my own here. Oh, I didn't. I just used Y hat again. I think it's supposed to be the predict proba, right? Okay, so I need to go back and update that. XGBoost, same dealio, knows has a higher accuracy rate, used only 100 trees in the forest, and again, it actually had the same performance as everything else. But let me go back through and do the predict proba, and hopefully then we get a difference in the rock score, which can then better drive the model selection. Last thing I just want to mention, I know it's the bottom of the hour. When we move this over to the slides, it's pretty straightforward. Basically, it wants you to look at the classification reports and confusion matrix for your favorite models and then draw some conclusions from it. I would probably have a couple of slides here that compare a couple of the different models. You can also include the train set accuracy if you want, but essentially, you're just going to be grabbing screenshots from this notebook and then putting them in the slides.
Yeah, I'm
And
going to a little later, I think, look at doing the modeling the way I think it should be right. In other words, dropping the flight number and also not scaling the dummies.
it's just because we technically pre-process the data in week 9, so then it uses that here. Because yeah, I would have done a pipeline and done all the
I
encoding
think
and the
it's a little bit
scaling
like
all in a pipeline.
I think it's a little bit like those cooking shows. Here's you make the ingredient, prepare the ingredients. Now we're going to have the one ready to go in the oven. Now we have the one that's already done.
Yeah, yeah. All right, let me see if this works. So for the rock score, I want to use y hat proba. Oh, there we go. That is how we're supposed to do it. All right, so yeah, let me go back through and update all of my notes using uh I'll have to rerun this whole notebook using predict proba. I don't know why I didn't catch that when I did this locally. That's my bad. And that'll also give you I would use this rock score proba as the like deciding factor for your model selection just because it'll likely change more. The probabilities change more versus the actual predictions. So just something to keep in mind. All right. Michelle, thanks for joining. I think we'll wrap class here. I don't have too much else to do. Once you're finished with the notebook, download it, right? And then you're going to upload it to your GitHub for your final submission as well. This is the last code you have to write for Module 10. To me, it's a lot more straightforward than the dashboarding notebooks, a little bit less like exercises you have to do on your own. And again, just remember the purpose of this is to give you advanced practice with cross-validation and grid search. So feel free to do some additional discovery on that on your own time as to kind of why we like cross-validation and grid search in wider machine learning workloads. All right. I will see. You're all like, I want to see what I want to see how good this predict proba this rock score does. But if you'll hold on 1 second, we can at least run it on the logistic regression. And we can see the difference here. Whoops. All right, last one here.
Except if you have does the proba, it won't work for the confusion matrix and the classification reports, I don't think.
No.
So you have to kind of make both. So if you get proba, then do a threshold thing to get one or zero for the other.
I think this should work. Let's see what happens here. Oh, we already broke it. Oh, because I download the rock score at the top. Oh yeah, I do.
Yeah, make sure you do that. I forget
Run
all the time.
all. Maybe just the run all that doesn't like. Oh, there it goes. I'm not sure why it's not running, but let's try this here. Then I gotta hop. I have a call I gotta be on. But I
Yeah,
want to
and
see if this
that's
will work
navigate.
for.
There's other stuff too.
All right, so yeah, for the log. Oh wow, so the logistic regression actually had a really good rock score. Closer to 1 is best. So that's actually really good. Wow.
Mhm.
And then for the support vector machine, hopefully, yeah, that was quick too. Oh, it doesn't. I have to, there's something on the support vector machine we have to do to get it to show probabilities. Oh no, my headphones just died. I think it's like, yeah, probability equals true, right? Yeah, there we go. I don't know why that's false by default. Probability equals true. Okay, so that had a ROC score of 875, which is less than the logistic regression. The decision tree took a while, right? Yeah, decision tree had a ROC, that was even worse this time, and it had a ROC score of 4.5. So yeah, that's garbage. We'll see about the KNN model. Had a ROC score of way less than the support vector machine and the logistic regression. So maybe the logistic would probably be the best. And then for the random forest, and then XGBoost, we'll let them run through and see which one's the best. I know the random forest took the longest to run. But maybe the logistic regression is the best solution here, and maybe that's also just because of the small sample size. All right, I gotta jump, but this has been fun. I will see you both in the forums, and I'll try and host an office hour next Monday. So feel free to swing by if you want to say hi or work through or talk through your submission. Otherwise, we'll look out for your submission in the classroom and look forward to the other forum posts that you all submit. And Michelle, if you still see issues with the week 10 forum, let me know and I'll just recreate it. Oh my God, people are uh slacking me.
The form's fixed, so the
Oh,
problem's
perfect.
gone.
Good. Yeah, there was like a permissions issue where it was like it wasn't assigned to the class. Okay. I'm not sure why the random forest is taking forever again. I believe in you. The XGBoost was so much faster. I wanted to have it on recording what the performance was, but I may just have to upload it because I gotta jump. All right, this has been fun. Thanks everybody. Thanks for the continued engagement in the class. Hopefully you learned something over the last 10 weeks. And if I don't see you again, it's been a pleasure to facilitate this for y'all. Oh, there it goes. Rock score of 83. And then the XGBoost also had a rock score of 88. So it looks like if you go by the rock score, since everyone had the same performance of like F1 score,
Good
accuracy, and
idea.
recall, the logistic regression performs the best. So I would still choose logistic regression here. So save, and then let me download this one as my final solution. And I would reference this one because I'm mad at myself for my local notebook not having the rock score done correctly. So yeah, I would say logistic is best, followed by SVM and XGBoost. All right, good stuff, all. I appreciate the time over the last 10 weeks. It's been a pleasure. Happy holidays if I don't see you, and hopefully we can say goodbye in the forums at some point. Thanks, all.